Now here we have the next type of integral, which is of the form 1 upon a sine square x plus b cos square x plus c, where a, b and c can be any constants. So what we see is basically there are quadratic terms or the square terms in sine and cos in the denominator. Now to solve this type of integral, there is a standard procedure, that is we multiply numerator and denominator by sec square x. We may do it by cosec square x also, but sec square x is just typical procedure. Now on doing this particular step, the integrals get reduced in such a way that in the denominator we get a quadratic expression in the tan x, alright, and by substituting tan x with another variable, we will get a integral of the previously known standard types, and which we solve by those methods. So let us see one example based on this type so that we'll have better idea. Now see, here we have to evaluate 1 upon sine square x plus 2 cos square x plus 3. So as we have seen, we have to multiply and divide by sec square x. So let us multiply here by sec square x divided by. Now when you multiply sine square x by sec square x, it is nothing but sine square x upon cos square x, which gives us tan square x, plus 2 cos square x and sec square x will nullify each other, so we are left out with just 2, plus this 3 will get multiplied with sec square x, right? Alright, so moving ahead, we have sec square x divided by tan square x plus 2 plus 3 into, now this sec square x can be broken as 1 plus tan square x, as we know. So if you see in the denominator, now we are going to get a quadratic expression in tan x. Right. So we have sec square x whole divided by, if we look here, tan square x multiplied with 3, so 3 tan square x plus the first tan square x, which gives us 4 tan square x, and then this 2 and this 1 getting multiplied with 3, that gives us plus 5, correct? So that is the denominator. So now to integrate this, what we observe is, suppose we substitute tan x with another variable, say t, then its derivative is automatically present because of the particular step that we took. So therefore let's put tan x by another variable, say t. So therefore using the substitution method, we know that sec square x dx is equal to dt, right? So on doing that, what we get is integral of 1 upon 4 t square plus 5 times dt. Now this is the integral of the familiar pattern. If you observe, we have the coefficient of quadratic term other than unity, so we must take 4 outside. So here we will have 1 upon t square plus 5 by 4 dt. So writing that in the correct required format, that is t square plus, now 5 by 4 can be written as root 5 by 2 the whole square, right? So if you observe, the denominator is of the form 1 upon variable square plus constant square, correct? So therefore we know that the answer of that integral is 1 upon a tan inverse of x by a. So that is 1 upon a is nothing but root 5 by 2 tan inverse of t upon root 5 by 2 plus c. So that finally gives us, cancelling 2, we have 2 into root 5, so that is 1 upon 2 root 5 tan inverse of into bracket. Now the 2 will go up and that will give us 2 upon root 5 into t, and at this stage we must replace t with the original expression. So that is, instead of t we now need to write tan x plus c, which is the final answer. So this is how we solve this type of integral by multiplying and dividing by sec square x.